Hello everyone, welcome to chemistry classes. Okay, so in the previous class I have given a homework. I hope all of you solved that homework, and I also have given the answer also. I hope all of you promptly solved that homework and compared with the answer. So now once again I will solve that and compare with the answer. So now see my question. Calculate the equilibrium constant. We have to calculate equilibrium constant, the value of Kc, for the reaction 2Fe3 plus 2I minus gives 2Fe2 plus I2 if E naught cell is equals to 0.235 volt. They have given the value of E naught cell, and by using this we have to calculate equilibrium constant. So what is the formula to calculate equilibrium constant? Do you remember the formula? Yes. E naught cell is equals to RT divided by NF, RT by NF ln Kc, RT by NF ln Kc. So now E naught cell is equals to, I'll write 2.303 RT divided by NF log Kc. I have converted a natural logarithm into log to the base 10. And for this reaction, see the reaction 2Fe3 plus gives 2Fe2 plus. 3 plus is converted into 2 plus, means conversion of 1 electron. Here 2 such type of atoms are there, so ions are there. 2 into 1, 2. Here 1 iodine loses 1 electron and 2 iodine loses 2 electron. So therefore for this reaction N is equals to 2. N is equals to 2. Here N is equals to 2. Now I am putting this value of R, value of T and F. We know that E naught cell is equals to 0.059 divided by 2 log of Kc. Log of Kc. And they have given value of E naught cell. How much it is? E naught cell is equals to how much? They have given 0.235 volt. 0.235 volt. Now therefore log of Kc is equals to this term comes here and it is multiplied with 0.235 into 2 divided by 0.059, and here volt is there. Now the log of Kc is equals to how much it is? Multiply. It is 7.9661. 7.9661. Now we want the value of Kc. Kc is equals to what? Log comes this side and becomes anti-log. Anti-log of 7.9661. And you also very much familiar about how to calculate anti-log of a number. So anti-log of a number is calculated by using only these numerals, and the number which are present before the decimal point are taken as 10 to the power. So here directly I will take 10 to the power 7, and I should see the anti-log of this number 0.9661. So in 0.9661, first 2 digit indicates row. We should see the 0.96th row, 6th column, and 1 main difference. So I'll see the anti-log. The anti-log 0.96 is something around here, 0.96, and 6th column 9247. It is 9247, and 1 mean difference, and corresponding mean difference 1 is 2. We have to add mean difference to the last digit of a number is added with the mean difference. Now it becomes 7 plus 2, 9, 4, 2, 9. So my anti-log value is 9249. Then I have to place a decimal point after first number. Okay, so this is my answer. The value of Kc is equals to 9.249 into 10 to the power 7. Okay, so like this we have to solve. So for any number we should read log and antilog in the same manner. In for logarithms there will be no decimal point. We should, if 4 numbers are given, first 2 number indicates row, third number indicates column, and the last number indicates mean difference, and mean difference to be added to the last digit of the number, isn't it? Okay, and you can write it down or you can take a screenshot, then you can write the problem. Now I go to next problem. So what's my next problem? Okay, the zinc silver oxide cell is used here. That is very much important problem. The zinc silver oxide cell is used in hearing aids and electric watches. See here in our watches there is a round cell, so round batteries are there. So those batteries are called as zinc oxide or zinc silver oxide batteries. Zinc silver oxide batteries, and they are used in calculators, watches, and everywhere. And they are also used in hearing aids. Hearing aids for the deaf people they use hearing aids. In those hearing aids they are also used zinc silver oxide batteries. So in that batteries the chemical reaction taking place, they have given zinc gives Zn2 plus 2 electrons. Which reaction is, whether it is oxidation or reduction, the zinc is converted into Zn2 plus, zinc atom is converted into zinc ion, zinc has lost 2 electrons, so it is oxidation reaction. So this is oxidation reaction. If the reaction is oxidation, here they have given oxidation potential. So please remember, the value of E naught is equals to oxidation potential of zinc, oxidation potential. And next come to the another reaction, Ag2O plus H2O, 2 electrons gives Ag plus 2OH minus. Here electrons are added, here undoubtedly this is reduction reaction, and for confirmation we will check which component is reduced. So let us write the oxidation state. Oxidation state of silver here it is +1, oxygen is -2, hydrogen +1, oxygen -2. Here silver is 0, oxygen -2, hydrogen is +1. So which is reduced? Yes, silver is reduced. Silver +1 is converted into 0, means it is reduced. So this reaction is reduction reaction. The given reaction is reduction reaction. If the given reaction is reduction reaction, the given potential is what? Reduction potential. And they have also mentioned degree. They have mentioned degree means standard reduction potential, and this value is standard oxidation potential. And so this is calculate E naught of the cell. We have to calculate standard electrode potential of the cell by using these two values, and delta G naught in joules. We have to calculate Gibbs free energy in terms of joules. So first we will see here such type of questions come for board examination as well as for NEET and JEE examinations. So this type of examples or problems are very important. ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಗಳು ನಿಮ್ಮ CET ಅಲ್ಲಿ JEE ಅಥವಾ NEET ಅಲ್ಲಿ ಬರ್ತವೆ. ಇವನ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಈ ತರ ಬರೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. So these problems are very important problems. So here by using these two reactions we have to calculate E naught of this cell as well as delta G naught of this cell. Okay, so how to calculate E naught of this cell? E naught cell is equals to what? Do you remember the formula? E naught cell is equals to the standard electrode potential of the cell is equals to standard electrode potential of the right side electrode minus standard electrode potential of left electrode. So usually on right hand side which electrode is used? Reduction is used, reducing electrode is used. So E naught of cathode, reduction occurs at cathode. So E naught cathode minus E naught anode. At anode oxidation occurs, at cathode reduction occurs. So right side always reduction takes place, left side always oxidation takes place. So we'll write E naught cathode minus E naught anode. So here to remember this thing, I'll give one simple thing. So let us imagine this is my cell. This is my cell. This is left hand side. This is right hand side. So here alphabetically which comes first, left or right? L, M, N, O, P, Q, R. So L comes first, so I will write first L. So left, then I will write right. Okay. In oxidation reduction, I don't know where my oxidation reaction takes place and where reduction takes place. So oxidation and reduction. So let us consider first letters O here, R here. Alphabetically which comes first? O comes first, then R. So means here oxidation, here reduction. Next, anode and cathode. Anode and cathode. So in anode and cathode. So once again let us consider first letters. Here A is my first letter, C is second letter. Which comes first alphabetically? A comes first. So here anode, here cathode. Isn't it? So like this you can remember very much easily. So here this indicates in a galvanic cell. This is only for galvanic cell. In a galvanic cell, left side oxidation reaction takes place. Left hand side oxidation reaction takes place, and that is called as anode. That is called as anode. Right hand side reduction reaction takes place, and that half cell is called as cathodic half cell. Cathodic half cell. So simply we can remember like this. So this is the simplest trick to remember our galvanic cell. Which electrode, in which electrode, which reaction takes place, like that. Okay. Now, so we'll solve E naught cathode, E naught anode. So here my cathode is, which is my cathode? At cathode which reaction takes place? Reduction reaction takes place. At anode oxidation takes place. So reduction takes place at cathode. Here the reduction potential of cathode is E naught is equals to how much? 0.344 minus. Now comes here, this is important. E naught cell is equals to what? E naught cell is nothing but the standard electrode potential of the cell. And according to IUPAC recommendations, we have to consider, or we must and should consider, standard reduction potential as the cell potential, isn't it? And for this also we have to consider standard reduction potential. Here also the standard reduction potential of the cathode minus standard reduction potential of the anode. But in this reaction they have given standard oxidation potential. See here, this is oxidation reaction. Now this potential is standard oxidation potential. But what we want? We need standard reduction potential. So if the standard oxidation potential is given positive, the quantity magnitude remains same, but the sign changes. Here E naught is equals to 0.76 volt. This is my standard oxidation potential of zinc. Oxidation potential means what? Zn bar Zn2 plus. This is oxidation potential. And the standard reduction potential of the very same zinc must be Zn2 plus bar. Zn is equals to, the magnitude remains same, the sign changes. If it is given positive, we should write negative. Minus 0.76 volt. So this is very important. The oxidation potential of the zinc is equals to reduction potential in magnitude but in opposite sign. Opposite sign. Here the oxidation standard oxidation potential of zinc is 0.76 volt. The very same for very same zinc, the standard reduction potential is minus 0.76 volt. Here what we should write, whether plus or minus? Yes, we have to take standard reduction potential. So minus 0.76 volt. I hope all of you understood about this, and let's go forward. So now what happens here? How much it is? 0.344 minus into minus plus 0.344 plus 0.76 volt. Okay, it is around 1.104 volt. So this 1.104 volt. Here our E0 cell value is found to be 1.10 volt. And my first part is over. E is over. Now next we have to calculate delta Z naught. Delta Z naught. So delta Z naught is equals to what? What is delta Z naught? What is the formula to calculate delta Z naught? Delta Z naught is equals to, I have got two equations, minus NF E0 cell, that is my first equation or first formula, and there is one more formula, delta Z naught is equals to minus RT ln K. Here which formula I have to use? Here I got the value of E0 cell, so I have to use minus NF E0 cell. NF E0 cell. Okay, next. So I know the value of F. Value of F is equals to how much? F is equals to 96,487 coulombs or coulombs per mole. Coulombs per mole. It's better to write coulombs per mole. Now N, see the reaction. Zinc is converted into Zn2 plus. 2 electrons are used here. 2 electrons in oxidation 2, reduction 2 means N is equals to 2. N is equals to 2. And we know the value of E0 cell. So very simple. Just put all these values. Minus 2 into 96,487 coulombs per mole. I'll remove them. Into, it is multiplied with what? 1.104 volt. Now how much it becomes? Minus 2 into 96,487 coulombs per mole into 1.10 volt. So it is found to be minus 2130.72 coulombs per mole volt. Coulombs per mole volt. So I will write minus 2130.72 coulombs volt per mole, and we know that coulombs volt is equals to joule. Coulombs volt is equals to joule. So minus 213.072 kilojoules per mole. Kilojoules per mole, isn't it? 10 to the power 0 plus 1 plus 2 plus 3. And for further simplification, I can write delta Z naught is equals to minus 2.13072 into 10 to the power 2 kilojoules per mole. So this is my answer. So here this means here into 10 to the power 0 is there. 10 to the power 0 means what? Multiplied with 1. So 10 to the power 0 is there. 10 to the power 0. If I count numbers on my left side, what happens? The 10 to the power increases. So 10 to the power 1, 10 to the power 2, 10 to the power 3. Up to here 3. 3 means what? Kilo. So I will write 213 minus 213.072 kilojoules per mole. Kilo means what? 10 to the power 3. And I can also further simplify this. If the point comes to these two more points, two more digits, then what happens? 10 to the power minus 10 to the power plus 1, 10 to the power plus 2, 10 to the power 2 kilojoules per mole. So this is my answer. I think all of you understood this. Take a screenshot and then we'll solve the next one. Okay, so better pause this video here and try to solve on your own. However, I will solve, so better try to solve on your own. So next one is first what we have to write, we have to consider, we have to read the question very clearly. The delta G naught for Daniel cell, they have mentioned Daniel cell, means I should know the chemical reaction. Delta G naught for Daniel cell has been found to be, they have given delta G naught value, it is around, the solution for the second problem, delta G naught is equals to minus 212.3 kilojoules at 25 degrees Celsius. 25 degrees Celsius, it is my temperature. T is equals to 25 degrees Celsius. Calculate equilibrium constant for the cell. So they have given delta G naught value and they asked for equilibrium constant Kc, and also they have given T, temperature. So the temperature is a hint for our chemical reaction. Our temperature is a hint to consider or to select a formula for the reaction. Which formula we have to use? We have got two formulae for calculation of delta G naught or equilibrium constant. So they have, however, they have given the value of T. So which formula we have to use? Delta G naught is equals to minus RT ln Kc. RT ln Kc. So now for this we have to take absolute temperature, but they have given temperature in terms of degree Celsius. So we have to convert this temperature into Kelvin scale, plus 273 Kelvin. How much it is? 25 plus 273, 298 Kelvin. Yes, it is 298 Kelvin. Now we'll take delta G naught is equals to minus 2.303 RT log Kc. Isn't it? We can write like this because ln is equals to what? 2.303 log. So now we will put the values. What is R? R is equals to what? 8.314 joules per Kelvin per mole. So now we will put the values. Minus 2.303 into 8.314 joules per Kelvin per mole into temperature how much? 298 Kelvin, 298 Kelvin into log of Kc, log of Kc. So here we can cancel out this, and one more thing, they have given this value also. How much it is? Delta G naught is equals to minus 212.3 kilojoules. Here they are given in terms of kilojoules. So let's take in terms of joules. They are given in terms of kilojoules. We have to multiply the whole equation with 10 to the power 3. Minus 212.3 into 10 to the power 3 joules. 10 to the power 3 joules. So I will write like this only. Minus 212. Directly I will take 10 to the power 3 as 300 joules. Isn't it? Is equals to minus 2.303 into 8.314 joules per Kelvin per mole, 298 Kelvin into log Kc. So is it possible to cancel out some terms? Yes, negative negative cancels out, joules cancels out, and per Kelvin also cancels out. What remains? Okay, nothing remains, actually per mole remains. Now I have to calculate the value of log Kc. Log of Kc is equals to this whole term. The log of Kc is equals to this whole term from this side. What happens? Divided by this 212,300 divided by 2.303 into 8.314 into 298. So log of Kc is equals to how much this? Calculate this one. It is around, so I need calculate for this. Yes, 37.207. The value is found to be 37.207. Now we will calculate Kc. Kc is equals to what? The anti-log of 37.207. So we are very familiar with antilog. So how to calculate antilog? The antilog of any number is equals to, just we have to take the number before decimal point as 10 to the power, yes, it is 10 to the power 37. Now see the antilog of 0.207. 0.207, how to see this? 0.20 row, 7th column. This is row, this is column. 0.20 means 0.20, the 7th column is 1611. So it is 1611. After one point, so after one number there is a decimal point. So the value is found to be Kc is equals to 1.611 into 10 to the power 37. So this is my answer. Okay. So next, third one. Okay. So I'll give third one as homework. The third problem as homework. We have to solve on your own. Third one. Okay. So first solve the problem and tomorrow I will solve that. Okay. Thank you so much for watching. And see one more thing. If you find this video is useful, please like, comment and share among your friends. And don't forget to subscribe to my YouTube channel. Thank you.